All right. Are we streaming? Are are we streaming? All right. What's up there? What's going on? Are are we streaming? All right. What's up there? What's going on? Wonderful. All right. I could hear my own voice. So, I've been seeing a lot of dooming on the Twitters lately, and on all the social medias, honestly, that we have reached code red. It is too late to do anything. Now, I refuse this doomerism on the grounds that I have a strong feeling that people read someone else tweeting about someone else tweeting about someone else tweeting, and it all eventually comes back to the IPCC. Uh, Now, it is definitely a problem. It is definitely a big problem, a world-ending problem, in fact. Maybe even the next apocalypse. Who knows? Uh, but the Twitter won't tell you the truth. The IPCC. Oh, so we're gonna read through it, see what it's all about, see if it's as bad as people say it is, see if there's anything that can be done, and we'll just have a blast researching this. Um, yeah, let's get to it. All right. I'll put this here so I can see your. And of course, if I come to stupid conclusions while going through this, that's what chat is for. That's what chat is for. All right, let's go. Climate Change 2021: The Physical Science Basis. Read the title. We are done. All right, great stream, guy. All right, let's get to it. This is no laughing matter. Introduction: The current state of climate, possible climate futures, climate information for risk assessment and regional adaptation, limiting future climate change. I think this should give us a good place. Of course, we're not going to read all 3,949 pages of this. We're obviously going to have to take some shortcuts, have some liberties. Introduction. This summary for policymakers. The Working Group 1, contribution of the IPCC 6th Assessment Report on the Physical Science Basis of Climate Change. The report builds on the 2013 Working Group 1 contribution to the IPCC. So this is the 7th report. Oh no, this is the 6th. Oh man, okay. I know they built to the 5th. The 5th report was the last report. And then I see. Okay. On the physical science basis of climate change, the report builds upon the 2013 Working Group 1's. So the 5th assessment came 2013. And the special 5th assessment report and the special reports came 2018, 2019. So, okay, so it was the 5th special report and then the 6th report. It's a weird numbering system you got there. Windows is offering you a job, my friend, of the AR6 cycle and incorporate subsequent. Okay, I know I sound like a climate denialist. I'll be clear. Climate change is a serious threat, and it is human caused. And if we do not seriously reconsider the way our economy is structured, we are all collectively fucked for good for eternity. That is my take. All right? Just so the dust is settled. Okay, let's keep reading this report. That is my take so far, and I have not been shown to be wrong so far. This SPM provides a high-level summary of the understanding of the current state of the climate, including how it is changing and the role of human influence, state of knowledge about possible climate features, climate information relevant to regions and segments. Based on scientific understanding, key findings can be formulated as statements of fact or associated with an assessed level of confidence, indicating using the IPCC calibrated language. The scientific basis for each key finding is found in the chapter sections of the main report and in integrated synthesis presented in the technical summary hereafter TS. and is indicated in curly brackets. The AR6 LUGI Interactive Atlas facilitates exploration of DC synthesis phasing and supporting climate change information across the WGI reference regions. A. The current state of climate. Since the AR5 Assessment Report 5, improvements in observationally based estimates and information from paleoclimate archives provide a comprehensive view of each component of the climate system and its changes to date. New climate model simulations, new analyses, and methods combining multiple lines of evidence lead to improved understanding of human influence on a wider range of climate variables, including weather and climate extremes. Time periods considered throughout this section depend upon the availability of observational products, paleoclimate archives, and peer-reviewed studies. True. A1. It is unequivocal. It is unequivocal that human influence has warmed the atmosphere, ocean, and land. Widespread and rapid changes to the atmosphere, ocean, cryosphere, biosphere have occurred. Alright, I know the common response to this is, alright, it's all been set in the stone, it is undebatable, and it should be for the most part. Honestly, like, my take is that most people should have this opinion. It's just that what I'm doing in this channel is different. I am reading through research, and I can't afford the same quick conclusion making that most other channels can. Yeah, so if you see me sort of trying to prove that 1 + 1 = 2, as I read this report, that is because that is exactly what I am trying to do in the scientific sense. The report is all here, it's all the raw data. Again, this is a boring channel, and we engage with these reports with as much as its content as possible. Sorry if that doesn't make sense. Let's continue. Okay, I'm going to zoom into this because I'm having a hard time reading it. Let's see if my stream does that too. Awesome. Shift it a bit. Observed increases in well-mixed greenhouse gas concentrations since around 1750 are unequivocally caused by human activities. Since 2011, measurements reporting AR5 concentrations have continued to increase in the atmosphere, reaching annual averages of 410 ppm for carbon dioxide and 1866, which is 1866 parts. I know parts per billion is more than parts per million. Parts per billion for methane, and 332 parts per billion for nitrous oxide in 2019. Land and ocean have taken up a near constant proportion, globally around 56% per year of CO2 emissions from human activities over the past 6 decades, with regional differences. High confidence. Yeah, references. Do I feel like going down the rabbit hole of references? I think I'll take it at its word. Each of the last 4 decades has been successfully warmer than any decade that preceded it since 1850. Global surface temperature in the first 2 decades of the 21st century, 2001 to 2020, was 0.99 degrees Celsius higher than 1850 to 1990. Shit. Global surface temperature was 1.09 degrees Celsius higher in 2011 to 2020 than 1850 to 1990, than 1850 to 1900, with larger increases over land than over the ocean. The estimate increase in global surface temperature since AR5 is principally due to further warming since 2003 to 2012. Additionally, methodological advances and new datasets contributed approximately 0.1 degrees Celsius to the updated estimate of the warming in AR6. Other GHG concentrations, PFC, land and ocean, are not substantial sinks for other GHGs. Okay. It is the likely range of human-caused global surface temperature increase from 1850 to 1900 to 2010 to 2019 to 0.8 degrees Celsius. So it is likely that humans caused 0.8 to 1.3 degrees Celsius of the warming, with a best estimate of 1.07 degrees Celsius. That's how much of the warming we have caused. It is likely that well-mixed GHGs contributed a warming of 1.0 degrees Celsius to 2.0 degrees Celsius. Other human drivers, principally aerosols, contributed a cooling of 0.0 degrees Celsius to 0.8 degrees Celsius. Yeah, these are all within likely ranges. You can have, so when I see words like likely and stuff, that just means this is our best guess. I forgot what the guy was. The philosophy of pragmatism. Pragmatism states that, the relevant truth is the best truth we can come up with the finite time we have for inquiring about the truth. So if through the scientific process we have come to the conclusion that it is likely, like the likely range of total human caused global surface temperature is 0.8 degrees Celsius, or increase, like the human caused global surface temperature increase is 0.8 degrees Celsius to 1.3 degrees Celsius, then it's just that all other guesses are the unlikelier. Like anything outside that range is unlikely. But what I can't determine from this is, all right, the likeliest range is 0.8 to 1.3 degrees Celsius. But you got absolute 0 to, well, okay. That means an unlikely range is 0 to 0.8 degrees Celsius. So, or we got negative 273 to 0.8 degrees Celsius. So you're telling me that negative 273 degrees Celsius to 0.8 degrees Celsius, is that less likely than 0.8 degrees Celsius to 1.3 degrees Celsius? From what I can tell from here, I think so. I think that's what the likely range implies. Okay, let me reiterate my problem with this wording here. Like in terms of, I think it can just be clearer. So when I say that, say you're in a lottery, all right? The average person buys one ticket in a lottery, but one person might buy 3,000 tickets in the lottery. Now, that person is more likely than other people to win the lottery, but that person is still very, very, very unlikely to win the lottery. You get what I'm saying? So, when they say the likely range of total human-caused global surface temperature increase from 1850 to 1900 to 2010 to 2019 is 0.8 to 1.3 degrees Celsius, what I'm getting from this, okay, is that 0.8 degrees Celsius to 1.3 degrees Celsius is that person that bought 1,000 lottery tickets, all right? Now, the ranges below that, like negative 273 degrees Celsius, or whatever absolute zero is, to 0.8 degrees Celsius. Like say each equivalent bucket in that range of 0.5 degrees Celsius, right? Are all of those put together more likely than the 0.8 degrees Celsius to 1.3 degrees Celsius? This is just a thought that crossed my mind. I just think they could be clearer. It is likely that well-mixed GHGs contributed to a warming of 1.0 degrees Celsius to 2.0 degrees Celsius. Other human drivers, principally aerosols, contributed a cooling of 0 degrees Celsius to 0.8 degrees Celsius. Natural drivers changed global surface temperatures by negative 0.1 degrees Celsius to 0.1 degrees Celsius. And internal variability changed. I think they'll go deeper into their confidence intervals and stuff as we go through the study. And internal variability changed it by negative 0.2 degrees Celsius to 0.2 degrees Celsius. It is very likely that well-mixed GHGs were the main driver of tropospheric warming since 1979, and extremely likely that human-caused stratospheric ozone depletion was the main driver of cooling of the lower stratosphere between 1979 and mid-1900s. Yeah, I really need to I'm sure they're talking about the confidence intervals here. Like, I am 80% sure that um, human caused global surface increase was between 0.8 to 1.3. I am, this percent sure. Yeah. Globally average precipitation over land has likely increased since 1950 with a faster rate of increase since the 1980s. Medium confidence. So that's like maybe 60% or something, I don't know. It is likely that human influence contributed to the pattern of observed precipitation changes since the mid 20th century, and extremely likely that human influence contributed to this is like 99%. We are 99% sure that human influence contributed to the pattern of observed changes in near surface ocean salinity. Mid-latitude storm tracks have likely shifted poleward in both hemispheres since the 1980s, with marked seasonality in trends. Medium confidence. For the southern hemisphere, human influence very likely contributed to the poleward shift of the closely related extratropical jet in the austral summer. Human influence is very likely the main driver of the current retreat of glaciers since the 1990s and the decrease in the Arctic sea ice area between 1979 to 1988 and 2010 to 2019, about 40%. Okay, wait. Wow, so we're 90% sure, or something like that. The main driver of the global retreat of glaciers, I believe glaciers is like the ice on land, which will actually raise the sea levels, as opposed to like the North Pole, where it's one big floating iceberg. So it's very likely, I'm going to assume, means like 90% plus sure. Even 80% plus sure qualifies very likely to me. About 40% in summer and about 10% March. There has been no significant trend in Antarctic sea ice area from 1979 to 2020 due to regionally opposing trends and large internal variability. Human influence very likely contributed to the decrease in northern hemisphere spring snow cover since 1950. It is very likely that human influence has contributed to the observed surface melting of the Greenland ice sheet over the past 2 decades. But there is only limited evidence with medium agreement of human influence on the Antarctic ice sheet mass loss. All right, so here it's like 50-50 or 50-50 on this, and we're not like this is pure uncertainty. Right? We are 0% sure. I don't know. Limited evidence. So the 99% confidence interval is between negative infinity to positive infinity is what I'm getting from this of human influence on the Antarctic ice sheet mass loss. All right. It is virtually certain that the global upper ocean, 99.99, has warmed since the 1970s, and extremely likely that human influence is the main driver. It is virtually certain that human-caused CO2 emissions are the main driver of current global acidification of the surface open ocean. Okay, so that's like 99.9% certainty. There's high confidence that oxygen levels have dropped in many upper ocean regions since the mid-20th century, and medium confidence that human influence contributed to this drop. Yeah, holy shit. Global mean sea level increased by 0.2, 0.15 to 0.25 meters between 1901 to 2018. The average rate of sea level rise was 1.3 millimeter per year between 1901 to 1971, increasing to 1.9 millimeter per year between 1971 to 2006, and further increasing to 3.7 millimeter per year between 2006 and 2018. High confidence. Yeah. Human influence was very likely the main driver of these increases, since at least 1971. Yep. Changes in the land biosphere since 1970s are consistent with global warming. Climate zones have shifted poleward in both hemispheres, and the growing season has on average lengthened up by 2 days, up to 2 days per decade since the 1950s in the northern hemisphere extratropics. Okay. If you're a climate denier at this point, burden of proof, it's been on you for a while. Um, Unfortunately, though, we find ourselves in positions where we are the therapist and not the patient, all right? Uh, and if you're trying to convince climate deniers, they're gonna not, they're gonna want to know what these confidence intervals are, like what the actual numbers are. I don't think they're gonna change their mind regardless, but you got to pretend that there's a semblance of rationality to the person you're talking to. Like if you are looking at this with a bias against climate change, you're gonna want to see the numbers. But I understand that if you're denying human-caused climate change and its impacts, we can't afford. We got to keep trying. We can't afford to lose hope. That's all I'm saying. All right, human influence has warmed the climate at a rate that is unprecedented in at least the last 2,000 years. So it wasn't the last since the Industrial Revolution. Oh no. It was since the Industrial Revolution, but it's unprecedentedly so. All right. Yeah, so you got these, and then yeah, the hockey stick, the classic hockey stick, and then these are all the areas of uncertainty, and it gets because as you get like notice how when you go from the past to the future, that uncertainty becomes less and less and less, right? So even if you were to take the highest projected temperature throughout, you know, all the way back from year one to year 2020, if you were to take the highest projected temperature, yeah, we're very much unprecedentedly warming. Change in the global surface temperature as observed and simulated using human and natural and only natural factors. So again, if you use only natural factors from 1850 to 2000, even if you take the highest points, we would have stayed a flat line. Here, if you were to take the lowest points of the human and natural caused, whatever, you still get the increase. So it's undeniable if you look at this. Panel A, changes in global surface temperatures reconstructed from paleoclimate archives, solid gray line. So yeah, they looked at paleoclimate archives and from direct observations that are solid black line, 1850 to 2020, both relative to 1850 1900s and decadally averaged. The vertical bar on the left shows the estimated temperature very likely range during the warmest multi-century period in at least the last 100,000 years, which occurred around 6,500 years ago during the current interglacial period Holocene. The last interglacial around 125,000. These warm periods were caused by slow, multimillennial orbital variations. The gray shading with white diagonal lines shows the very likely ranges for the temperature constructions. Yeah, these are like the confidence intervals, the very likely ranges. You can still be outside the range, it's just very unlikely. Paddle B, changes to global surface temperature over the past 170 years. Black line, relative to 1850 to 1900 and annually averaged compared to the CMIP6 climate model simulation, see box SPM1. The temperature response to both human and natural drivers, brown, and only natural drivers, solar and volcanic activity, green. Solid colored lines show the multi-model average, and colored shades show the very likely range of simulations. Yeah. All right. Observed warming is driven by emissions from human activities, with greenhouse gas warming partly masked by aerosol cooling. So we have observed warming 2010 to 2019 relative to 1850 to 1900 is looks like 1.1-ish degrees Celsius. What is this? I forgot. What does this black line mean? Oh shit! Is this a box and whisker plotter? I forgot how to read those. Oh no! Oh man, okay. This is a bar graph, right? It's on average gonna be. It's always in the middle of these lines. Oh, this is such a stupid way to draw this. I hate it so much. Okay, the lowest that this bar is gonna be is like 0.8, and the highest is like 1.1. I see. I hate reading this so much. So total human influence is between 0.6. No, yeah, it's between like 0.7 or 0.8 to like 1.3 degrees Celsius of the warming. And the aerosols, which I guess is like the coolants. Oh, I can see some people saying, "Oh, why don't we put more aerosols in the atmosphere?" We might come to a desperate point where that might actually be like a proposed solution. There's no telling what that could fuck up, but I can definitely see. Oh, why didn't like the ozone layer is pretty important. I remember kind of lost our ozone layer to an aerosol before, but yeah. Contributions 2010 to 2019 warming relative to 1850 to 1900, assessed from radiative forcing studies. Carbon dioxide, methane, nitrous oxide. Yeah, a bunch of chemicals that stuff happened. Cool. Observed global warming and its very likely range. True. All right. The scale of recent changes across the climate system as a whole and the present state of many aspects of the climate system are unprecedented over many centuries to many thousands of years. In 2019, the atmospheric CO2 concentrations were higher than at any time in at least 2 million years, high confidence, and concentrations of CH4 and N2O were higher than at any time in at least 800,000 years, very high confidence. Since 1750, increases in CO2 and CH4 concentrations far exceed, and increases in N2O are similar to the natural multimillennial changes between glacial and interglacial periods over at least the past 800,000 years. Very high confidence. I need drink water. My mouth is getting dry. Global temperature has increased faster since 1970 than in any other 50-year period over at least the last 2,000 years. High confidence. Temperatures during the most recent decade, 2011 to 2020, exceed those of the most recent multi-century warm period, around 6,500 years ago. 13. Medium confidence. Prior to that, the most recent warm period was about 125,000 years ago, when the multi-century temperature 0.5 degrees Celsius to 1.5 degrees Celsius to 1850 to 1900. Yeah, it's just faster increase in global temperature. And the Arctic sea ice has reached its lowest level since the 1850. Okay. I don't know. So isn't it that we should care about? I mean, don't get me wrong. Arctic sea ice is bad for the wildlife there and whatnot. But I always thought of the Arctic sea ice as because it isn't on the land, that it's not a problem. Like it's just a floating chunk of ice in the ocean. And the Antarctic sea ice, since it is on land and it's glaciers and it melts into the water, that raises the sea level. I remember it's like the ice cube displacing water analogy. If you put an ice cube in water, it displaces the water by a certain amount and it'll melt. The displacement will decrease, but like the ice becoming water will increase and they offset each other. But that's a very simplified analogy and might have no bearing in the real world. It's just a thought. Late summer Arctic sea ice was smaller than at any time in at least the past 1,000 years. Medium confidence. The global nature of glacier retreat, with almost all the world's glaciers retreating synchronously since the 1950s, is unprecedented in the last year. Great glaciers melting will fuck you up. Global mean sea level has risen faster since 1900 than over any, at least the last 3,000 years. Yep. The global ocean has warmed faster over the last century than the end of the last deglacial transition. A long-term increase in surface open ocean pH occurred over the past 50 million years. Yep, it's becoming more basic. Wait, no, not becoming. The surface ocean pH, if the pH increases, it becomes more basic, yeah. And surface open pH is as low as recent decades is Oh wait, no. Okay, the ocean. Fuck. Okay, how do I interpret this? A long term, so over 50 million years, the pH of the ocean should have been increasing. And for it to be as low as it is unusual, especially in the past 2 million years with medium confidence. Yeah, a lot of this is a lot of spaghetti to read. My mouth feels dry reading it. I need to keep drinking water. Human-induced climate change is already affecting many weather and climate extremes in every region across the globe. Evidence of observed changes in extremes such as heat waves, heavy precipitation, droughts, and tropical cyclones, and in particular their attribution to human influence, has strengthened since AR5. It is virtually certain that hot extremes, including heat waves, have become more frequent and more intense across most land regions since the 1950s, while cold extremes, including cold waves, have become less frequent and less severe. Yep, increased hot waves. Yeah, heat waves are partly due to human. Some heat waves have been extremely, hot extremes would be extremely unlikely to occur without human influence on which means they are extremely likely to occur with human influence on the climate system. You can read that both ways and you'd be fine. Marine heat waves have approximately doubled in frequency since the 1980s. High confidence and human influence has very likely contributed to most of them since at least 2006. The frequency and intensity of heavy precipitation events have increased since the 1950s over most land area for which observational data are sufficient for trend analysis. High confidence in human-induced climate change is likely the main driver. Human-induced climate change has contributed to increases in agricultural and ecological droughts in some regions due to increased land evapotranspiration. Medium confidence. Yeah, a lot of these are at least a medium confidence and worth considering. Decreases in global land monsoon precipitation from the 1950s to the 1980s are partly attributed to human-caused northern hemisphere aerosol emissions, but increases since then have resulted from rising GHG concentrations and decadal to multi-decadal internal variability with medium confidence. Over South Asia, East Asia, and West Africa, increases in monsoon precipitations due to warming from GHG emissions were counteracted by decreases in monsoon precipitation due to cooling from human-caused aerosol over the 20th century. High confidence. So yeah, you're getting both extremes. You're getting extreme monsoons in some places and extreme droughts in other places. And monsoons aren't good either if it's too high. Yeah, you can you can cause flooding and kill off crops by drowning them. Increases in West African monsoon precipitation since the 1980s are partly due to the growing influence of GHGs and reductions in the cooling effect of human-caused aerosol emissions over Europe and North America with medium confidence. Okay. It is likely that the global proportion of major tropical cyclone occurrence has increased over the last 4 decades, and the latitude where tropical cyclones in the western North Pacific reach their peak intensity has shifted northward. These changes cannot be explained by internal variability alone. We're like 60 to 80% sure of this, maybe. There is low confidence in long-term multi-decadal to centennial trends in the frequency of all category. Yeah, so we're not sure, how many cyclones we're going to get in the future. It could be very low to very high. It's unpredictable. Event attribution studies and physical understanding indicate that human-induced climate change increases heavy precipitation associated with tropical cyclones. High confidence. But data limitations inhibit clear detection of past trends on the global scale. So yeah, based on this, yeah, we aren't sure. We aren't sure how many cyclones we're going to get in the future. There's low confidence here. You can inform me if I'm wrong, but people say that we are expected to get just cyclones. It's not to say about hurricanes. I think there's a difference. But yeah, if we're unsure of the trends, we shouldn't be saying that they will happen. Human influence has likely increased the chance of compound extreme events. Since the 1950s, this includes increases in the frequency of concurrent heat waves and droughts on a global scale. This is already bad enough, by the way. We don't even have to talk about the hurricanes to know that this is already bad. Fire weather in some regions of all inhabited continents with medium confidence, and compound flooding in some locations, medium confidence. Okay. When a bunch of things are medium confidence, you can be sure at least 60% of it to 80% of it is right. So, yeah, put it at that. Type of observed change in hot extremes: increase, decrease. So the hot extremes of every world has increased since the 1950s. Mm-hmm. With high confidence overall. Okay, I see. And type of observed change in heavy precipitation increase. So with precipitation, just a lot of limited data and low confidence, low to medium confidence. Yeah. There's high confidence of human contribution to hot extremes, and there is limited evidence, low or medium confidence uh, to observe change in heavy precipitation. Okay. Observe change in agricultural or ecological drought. Okay, so low and limited human, low due to a limited agreement. So yeah, there is a low confidence in human contribution and low agreement in the type of change. I see. So increase in it has been increasing with medium to low confidence in some places, low to medium, but overall, it's in most places it is just low agreement and low confidence in the impact of human contribution to that. I think that's okay. Northwestern North America. Okay, yeah. Panel A for hot. The evidence is mostly drawn from changes in metrics on daily maximum temperatures. Regional studies using indices are used in addition. Red hexagons indicate regions where there is at least medium confidence and an observed increase in hot extremes. Panel B for heavy precipitation. Yeah. So yeah, not only that, not only so there's never been a decrease in heavy precipitation. It's only been increasing, which is crazy because some change in heavy precipitation. Okay. So, mhm. So whenever you see a colored tile, there is at least medium confidence that this type of change has been observed. All right. So there's a high confidence, extremely high, in fact, medium to high, most part, that hot extremes have been increasing globally. And overall, there is a medium to high confidence that humans have contributed to that change. Here, there's a lot of limited data and low agreement that this type of change has even been happening. But in these colored tiles, there is at least medium confidence that heavy precipitation, the change in heavy precipitation has increased since the 1950s. However, most of these are low, have low confidence in the human contribution to this. All right. And the observed change in agriculture and ecological drought. Uh, yeah, so we see that the colored tiles, which aren't many, it's like less than 50% of it are colored, most places, 12 places in fact, they have increased with medium confidence. There's certain things that have increased since the 1950s, um, but there's medium to low confidence that this is a human caused phenomenon. In NAU, which is I guess North Australia, if I'm not correct, Asia, yeah, northern Australia. Here, there's a medium confidence interval that the drought has decreased, but there's low confidence that humans have contributed to this decrease. But overall, drought has been increasing. Okay. A4. Improved knowledge of climate processes, paleoclimate evidence, and the response of the climate system to increasing radiative forces gives a best estimate of equilibrium climate sensitivity of 3 degrees Celsius within a narrower range compared to AR5. Human-caused radiative, what's radiative forcing? Of 2.72 watts per meter squared. Oh, I guess the intensity of heat waves in 2019 relative to 1750 has warmed the climate system. This warming is mainly due to increased GHG concentrations, partly reduced by cooling due to increased aerosol concentrations. Radiative forcing has increased by 0.43 watts per meter squared, 19% relative to AR5, of which 0.34 watts per meter squared is due to increase in GHG concentrations since 2011. The remainder is due to improved scientific understanding and changes in the assessment of aerosol forcing, which include decreases in concentration and improvement in its calculations. Define what's radiative forcing. I'm thinking. Okay, yeah, it's how hard the sun is beating down based on this picture. Positive radiative forcing means Earth receives more incoming energy from sunlight than it radiates in space. Yeah. So more coming in and less going out. There's a certain healthy amount of radiative forcing, I'm guessing, because we need to keep things warm even when it's night. But yeah, this is all high confidence. Human-caused net positive radiative forcing causes an accumulation of additional energy heating in the climate system, partly reduced by increased energy loss to space in response to surface warming. The observed average rate of heating of the climate system increased from 0.5 watts meter squared for the period 1971 to 2006 to 0.79 watts per meter squared from the period of 2006 to 2018, and this is a high confidence thing. Ocean warming accounted for 91% of the heating in the climate system, with land warming, ice loss, and atmospheric warming accounting for 5%, 3%, and 1% respectively. Yep, okay. So land warming causes 5% of them. Alright. So when people say that don't get me wrong, it's kind of uncomfortable when you live in like a place where the pavement is all heated from absorbing the light. But to say that this is responsible for heating in the system is, well, it's only responsible for 5% of the heating in the system. Most of it's coming from the ocean. Yeah, we're ice sheet loss, sea level rise, ice sheet and glacier mass loss were dominant. So wait, let me look at this again. Heating in the climate system has caused global mean sea level rise through ice loss on land and thermal expansion from ocean warming. Yeah, if you heat water, it will expand. I'm guessing, like because space between particles and whatnot increases. Thermal expansion explained 50% of sea level rise during. Jesus, so just because the sea is warmer, it expands. Define thermal expansion. Totally forgot that hot objects of oceans. Yeah, like if you heat stuff up, it expands, so the ocean is no different. Interesting. Jesus, well, ice loss from glaciers contributed 22%, and ice sheets 20%, and changes in land water storage 8%. Hmm. The rate of ice sheet loss increased by a factor of 4 between 1992 to 1999 and 2010 to 2019. Together, ice sheet and glacier mass loss were the dominant factors to global mean sea level rise during 2006 to 2018. And there's high confidence with this. The equilibrium climate sensitivity is an important quantity used to estimate how the climate responds to radiative forcing. Based on multiple lines of evidence, the very likely range of equilibrium climate sensitivity between 2 degrees Celsius and 5 degrees Celsius. Wait, sorry. Let me read that again. Based on multiple lines of evidence, the very likely range of equilibrium climate sensitivity is between 2 degrees to 5 degrees with high to medium confidence. The AR6 assessed best estimate is 3 degrees Celsius with a likely range of 2.5 to 4 degrees Celsius compared to 1.5 degrees Celsius to 4.5 degrees Celsius in AR5, which did not provide a best estimate. So radiative forcing doesn't say increase, so it can increase. I don't get what's equilibrium. Define equilibrium climate sensitivity. Cool or warm after a change in the climate system. Okay, I did not get that. I see. So it's okay. Well, let me look at that one more time because I keep. All right. So from my understanding of this, radiative forcing can either increase or decrease climate sensitivity, which can exacerbate or limit feedback loops. After increasing CO2 levels, there is an initial warming. This warming gets amplified by the net effect of feedbacks. All right. And there are self-reinforcing feedbacks, including the melting of sunlight reflecting ice and higher evaporation, increasing average atmospheric water vapor, greenhouse gas. So the climate sensitivity increases with radiative forcing, which increases the intensity of feedback loops. I see. So I still don't know how this works out in a math equation, I guess, but this doesn't. I can't make a good argument for why this is important. I can just. If someone in the chat can tell me, but there's no one in the chat. Because this is a 0 subscriber YouTube channel. A set of 5 new illustrative emission scenarios is considered consistently across this report to explore the climate response to a broader range of greenhouse gas, land use, and air pollutant features than assessed in the AR5. This set of scenarios drives climate change model projections of changes in the climate system. These projections account for solar activity and background forcing from volcanoes. Results over the 21st century are provided for the near term, mid-term, and long term relative to the 1850 to 1900s, unless otherwise stated. Box SPM.1 Scenario Climate Models and Projections. This report assesses the climate response to 5 illustrative scenarios that cover the range of possible future development of anthropogenic drivers of climate change found in the literature. They start in 2015 and include scenarios with high and very high GHG emissions, SSP3, and CO2 emissions that roughly double from current levels by 2100 and 2050. Respectively, scenarios with immediate GHG emissions and CO2 emissions remaining around current levels until the middle of the century, and scenarios with very low. Okay, I don't get these. These are just scenario climates. Okay, I'm gonna see the graphs and then get back to this because I don't understand anything this is saying. But I'm gonna get some water first. I have ran out of my water. I will be back. All right, I'm back. Awesome. All right, let me read this again. All right. A set of 5 new illustrative emission scenarios is considered consistently across this report to explore the climate response to a broader range of GHG, land use, and air pollutant futures than assessed in AR5. This set of scenario drives climate model projections of changes in the climate system. These projections account for solar activity and background forcing from volcanoes. Results over the 21st century are provided for the near-term, mid-term, and long-term relative to the 1850s and 1900s, unless otherwise stated. All right, we're basically about to see the 5 futures, and perhaps I predict that the best future is still something pretty shitty. I think this is what's causing people to doom and gloom right now. All right. Scenario climate models and projections. Box SPM. So what are these SPMs? I don't know what SPM means. But this box is a blue box, I guess, and that's what that means. Okay, so the high and very high GHG emission scenarios are SSP3 7.0 and SSP5 8.5. I'm guessing the higher the SSPs, the more CO2 there is. And CO2 emissions that roughly double from current levels by 2100 and 2050, respectively. Scenarios with intermediate GHG emissions, SSP to 4.5, and scenarios with very low and low GHG emissions and CO2 emissions declining to net zero around or after 2050. So yeah, followed by varying levels of net negative CO2 emissions, SSP 1 to 1.9 and SPP 1 2.6. Okay. Yeah, it may vary depending on various factors. All right. This report assesses results from climate models participating in the coupled model intercomparison project base phase 6, CMIP6 of the World Climate Research Program. These models include new and better representation of physical, chemical, and biological processes, as well as higher resolution compared to climate models considered in previous IPCC assessment reports. This has improved the simulation of the recent mean state of most large-scale indicators of climate change and many other aspects across the climate system. Some differences from observations remain. For example, in regional precipitation patterns, period, no comma. The CMIP6 historical simulations assessed in this report have an ensemble mean global surface temperature range within 0.2 degrees Celsius of the observations over most of the historical period. And observed warming is within the very likely range of the CMIP6 ensemble. However, some CMIP6 models simulate a warming that is either above or below the assessed very likely range of observed warming. I don't get what this means. Okay, future emissions cause future additional warming, with total warming dominated by past and future CO2 emissions. So these are the scenarios. Gigatons of carbon dioxide per year emitted, with SS 1.9, 4.5. Okay. All right. So at 2015, what we'll actually see more methane in the SSP3 7.0. These are just different scenario mixes. Okay, I see. So SSP3 7.0 sees higher emissions in everything else other than CO2. Okay. Don't get how they why not just control for these things? Why have maybe they'll explain this more. I don't know. So SSP 1 to 1.9 and 2.6. Those are like the best case scenarios. The worst case scenarios we'll see like okay, so we'll see anywhere between a 5.5 to a 3.5 degrees Celsius warming with the SSP5 scenario. So what is the SSP5? What scenario are we in right now? Oh. Honestly, it depends. If we increase, not exponentially, but quadratically, I guess, the amount of CO2 over time, we get an SSP5. But we have to be in SSP 1 2.6, we are going to reach the 2-degree warming threshold. And SSP, we're likely within a confidence interval going to be above the 2.2 degrees threshold. In all the other SSPs, in SSP2 4. And SSP2 4.5, this is just a moderate scenario. And this is 2081 to 2100 relative to 1850 to 1900. Apparently 2 degrees is that tipping point. SSP2 4.5, it's not a question. With SSP 1 to 2.6, it's kind of a question. In SSP 1 to 1.9, it's a very, very good question. In fact, it might be answered by the fact that we are not going above that 2 degrees. But that's SSP 1. I don't know if that actually made sense, but. Yeah. Okay, let's look at the analyses. Panel A, annual anthropogenic human cause. So panel A, yeah, one criticism I have with this study, like, I wish they explained, like, they didn't explain this well. I really wish they just controlled for, like, the other, like, they don't vary that, do they vary that much? I guess the impacts of them, no, they vary significantly, right? I think oh, I think they explained that up here. I may have just missed the explanation. Maybe someone can tell me why they don't control for the non-GHGs, because I'm too stupid to figure that one out, or they don't communicate it well. Either one of those two things. Let me look at that 2-degree tipping point thing. I want to make sure it is that. Probably wondering why I go to Wikipedia more than everything else, because Wikipedia consists of the everything else. Okay. Global surface temperature will continue to increase until at least the mid-century under all emission scenarios considered. Global warming of 1.5 degrees Celsius and 2 degrees Celsius will be exceeded during the 21st century unless deep reductions in CO2 and other greenhouse gas emissions occur in the coming decades. Hmm? So in the very low GHG emission scenario, SSP 1.1.9, total observed warming is between 0. Wait, what? 1.0 to 1.8? This contradicts what I saw there? Am I just stupid? Then what the hell was this? This is, oh, this is 2081 to 2000 to 1850 to here. No, this is also 2081 to 2100. So, what? This is like 0.9 to like 1.8. Here it's 1.4 to 2. Okay, let me read that again now. Yeah, it's still very likely to be high by 1 degree to 1.8. I just wish they called it 0.9 instead of 1. By 2.1 to 3.5, like I see no reason why they just couldn't make this 0.9. But alright, 2.1 to 3.5. What? In SS? No, it's gonna be between 1. What? What the hell? Okay, this refers table SPM1. What's this thing then? This shit is so poorly communicated. Like, yeah, like SSP Oh no, 2.45. Wait, what? Okay, let me read. I've got to read this shit because I am going bizarro. Read it one more time. Okay. SSP 1 to 1.9 is going to be SSP 1 to 1.9. We are going to see a warming of 0. Oh no, this is 1 to 1.8. This thing is what messed me up. In SSP 1.26. Did they even talk about SSP 1.26? No, they just went straight to SSP 2.45. Yeah, okay. I thought I was going insane for. No. Yeah. Okay, I see. Whew. That was a lot to read. Changes in global surface temperature, which are assessed based on multiple lines of evidence for like a 20-year. Okay. So SSP 1.19, 1.26, all of these, we're not going to hit our 1.5 degrees Celsius. Or we might. We're not going to go above 2 degrees Celsius within like by 2040. All right. There's some time. In the midterm, 2041 to 2060. That's 20 years. We are going to see. Fuck, we hit tipping point in SSP in like the best and the long term. Okay, then we stay within the tipping point, 1 to 1.8 degrees Celsius. But we hit tipping point. Holy shit! This SSP 1 to 1.9 degrees Celsius is like SSP. This is like the best case scenario. Yeah. Everything else goes to shit in the long term. Or I mean, I wouldn't doom at SSP 1 2.6 because we can still hope for something underneath 2 degrees Celsius, but we're gambling at SSP 1 2.6 and SSP 2 4.5 to SSP 5 8.5. There is no question we're fucked. Yeah, 100%. Wait, what? Okay. Global warming of 2 degrees Celsius would extremely likely be exceeded in the intermediate scenario. No, it's not. Oh no, extremely likely. Yeah. Holy shit. Like none of this is certain. It's all extremely likely. Yeah. And unlikely to be exceeded in SSP 1 2.6. It's still a gamble. Crossing the 2 degrees Celsius in the midterm period is very likely to occur. Yeah. Under the very high GHG emission scenario, 5.85. Likely to occur under the high GHG emission scenario, 3.7. And more likely than not to occur in the intermediate GHG emission scenario. Okay. Here's my question. I'm going to go back to that graph again. Is there any way that we can get from this scenario down to this? So like we're here right now, so it can feel like whatever path we take is the inevitable one. Tomorrow we could be, or next year I should say, we could be somewhere between SSP 1 to 2. If we can stay between SSP 1 to 1.9 and SSP 1 2.6, even then I'd say we're gambling. But it's a gamble that's in our odds, but man, are we gambling. We're gambling. If we are between SSP 2 4.5 to SSP 1 1.26, as in if our projection is anything here, we could still, I don't know, I'm going to keep reading this. I don't want to make a conclusion yet. Global warming of 1.5 degrees Celsius relative to 1850 to 1900 would be exceeded during the 21st century under the intermediate, high, and very high scenarios considered in this report. Under the 5 illustrative scenarios in the near term, 2021 to 2040, the 1.5 degrees Celsius global warming level is very likely to be exceeded. Oh, wait, let me read this again. So much terminology being thrown around. All right. Under the intermediate, high, and very high scenarios are like no-goes. They're no-go zones. Under the 5 illustrative scenarios in the near term, the 1.5 degrees Celsius global warming is very likely to be exceeded under the very high, likely to be exceeded under the intermediate and high GHG scenarios, more likely than not to be exceeded under the low GHG emission scenario. Yeah, I think we have to hit 1.5 degrees Celsius. We have to be below that by the end of the decade. And more likely than not to be reached under the very low GHG emission scenario. Furthermore, for the very low GHG emission scenario, it is more likely than not that global surface temperature would decline back to below 1.5 degrees Celsius toward the end of the 21st century, with a temporary overshoot of no more than 0.1 degrees Celsius above 1.5 degrees Celsius global warming. Okay, what should we do to be within SSP 1 1.1 to 1.9 is what I want to know, because our entire economy needs to be centered around doing that goal. Of course, taking into account trade-offs. Global surface temperature in any year can vary above or below the long-term human-induced trend due to substantial natural variability. The occurrence of individual years with global surface temperature change above a certain level, for example 1.5 degrees Celsius to 2 degrees Celsius relative to 1850 to 1900, does not imply that this global warming level has been reached. Okay, wait. Yeah, okay. It does not, but we do have reason to be scared. As long as there is like variability, as long as it goes down and down, then yeah. Many changes in the climate system become larger in direct relation to increasing global warming. They include increases in the frequency and intensity of hot extremes, marine heat waves and heavy precipitation, agriculture and ecological draws in some regions, and proportion of intense tropical cyclones, as well as reductions in Arctic sea ice, snow cover, and permafrost. This is this is all bad for the economy. It is virtually certain that the land surface will continue to warm more than the ocean surface, likely 1.4 to 1.7 times more. It is virtually certain that the Arctic will continue to warm more than the global surface temperature, with high confidence above 2 times the rate of global warming. Mm-hmm. With every additional increment of global warming, changes in extremes continue to become larger. For example, every additional 0.5 degrees Celsius of global warming causes clearly discernible increases in the intensity and frequency of hot extremes, including heat waves, very unlikely, and heavy precipitation, high confidence, as well as agricultural and ecological droughts. Discernible changes in intensity and frequency of meteorological droughts, with more regions showing increases than decreases, are seen in some regions for every additional 0.5 degrees Celsius of global warming. Increases in frequency and intensity of hydrological droughts become larger with increasing global warming in some regions. There will be an increasing occurrence of some extreme events unprecedented in the observational record with additional global warming, even at 1.5 degrees Celsius global warming. Projected percentage changes in frequency are higher for rare events. Okay, yeah. So as you increase the heat, you're very likely to increase the hot extremes, including heat waves, heavy. But doesn't that hold on, let me move up this in a new tab because this goes all the way back somewhere. So I'll go back here. You see some contradiction somewhere. I don't know if it's a contradiction actually. This is just what I perceive to be a contradiction. Okay. Heavy precipitation. There is there has been a change in an increase in heavy precipitation with the medium confidence, as we discussed previously. Yet it's low to medium confidence that this is human caused, but also human caused climate change of 0.5 degrees Celsius. Yeah, no, maybe I'm reaching. Okay, I can see how this could be perceived as reaching. You know, I'm a, I mean, it is a fair assumption to make though, right? That this 0.5 degrees Celsius will be human caused. Will that make all of these turn green? All of these green things into 3 dots. That's what I'm wondering. I mean, I believe this. They put in the work studying this. The burden of proof is for someone to disprove this with better studies. Discernible changes in intensity and frequency of meteorological droughts, with more regions showing increases than decreases, are seen in some regions for every additional 0.5 degrees Celsius of global warming. Median confidence increases in frequency and intensity of hydrological droughts become larger, with increase in global warming in some regions. Median confidence. There will be an increasing occurrence of some extreme events unprecedented in the observational record, with additional global warming. Even at 1.5 degrees Celsius global warming, projected percentage changes in frequency are higher for rare events. Some mid-latitude and semi-arid regions and the South American monsoon regions are projected to see some of the highest increase in the temperature of the hottest days, at around 1.5 to 2 times the rate of global warming. High confidence. The Arctic is projected to experience the highest increase in the temperature of the coldest days, at about 3 times the rate of global warming. High confidence. With additional global warming, the frequency of marine heat waves will continue to increase with high confidence, particularly in the tropical ocean and the Arctic. Medium confidence. It is very likely that heavy precipitation events will intensify and become more frequent in most regions with additional global warming. Yeah, a lot of bad shit's about to increase. Yeah, ice is decreasing, melting. Permafrost thawing. Wait. Is likely to be practically sea ice free in September, at least once before 2050. Under the 5. What? With more frequent occurrences for high warming levels. Wow. There is low confidence in the projected decrease of Antarctic sea ice. Okay, that's at least somewhat of a good thing. Well, no, that doesn't mean it's going to project. It's just we're not sure how much it's going to project by. Man. I don't know. Okay, how much more of this do I have to read? Let me just go back up to contents. I've been reading for a while. Yeah, before I form a take, I'm just gonna have these research streams up just so. Okay, so how tired am I? I think I'm fairly tired. I'm just going to continue this stream tomorrow. But thank you for watching, to the 0 people that watched. And yeah, well, I'll continue this either tomorrow. I was supposed to do the what do you call it, the credit union versus banks thing as well, but I'm going to focus on the IPCC because this is a more pressing issue. I'll continue it tomorrow or day after, depending on when I have the time. And I'll see you later. See you guys, and goodbye.